Hi guys, happy Wednesday to my even classes and happy Thursday to my odd classes. Today we are going to continue working on EQ5 over arithmetic and geometric sequences. I left my stylus pen at school, so I'm going to do my best to get through this lesson without using it to write on the screen. First thing you have today are 3 more word wall words or word wall phrases. So make sure you go ahead and hit pause and add these to your quarter 2 word wall list. These will be terms 5, 6, and 7. So you're already halfway through your 15 word wall words because this first EQ is chock full of them. So your first phrase or word is term of a sequence, an individual number, figure, or letter in the sequence. So if my sequence was 2, 4, 6, 8, 10, 2 is a term, 4 is a term, 6 is a term, 8 is a term, 10 is a term, and so on. Your next one is explicit formula, a formula for calculating the value of each term of a sequence using the term's position in the sequence. We're going to learn about this today. And the recursive formula expresses each new term of a sequence based on the preceding term in the sequence. So again, go ahead and pause your screen now to copy these onto your word wall list. All right, so moving on. Let's review from yesterday. So what is the difference between geometric and arithmetic sequences? So hopefully you remember that an arithmetic sequence adds or subtracts a common term. We call that addition or subtraction of a common term the common difference. Whereas a geometric sequence multiplies or divides a common term, and we call that the common ratio. With geometric sequences, we have to remember that when we are dividing, when we write the common ratio, we write it as a fraction. It's called the reciprocal. So when I divide by 3, I would write that as 1 over 3 or 1/3. When I divide by 5, I'm going to write that as 1 over 5 or 1/5. If I divide by 10, 1 over 10. If I divide by 12, 1 over 12. If I divide by 5 million, 1 over 5 million. Okay? If it's a whole number that we are dividing by, we're going to put a 1 over it. Okay, we're going to put a 1 over it. Why? Because dividing by a whole number is the same as multiplying by its reciprocal. It's the same thing. And you're going to see why it makes a difference when we get into these formulas today. All right, so go ahead and take a moment to answer questions 1 and 2. Oh, I guess I should tell you what to do. On questions 1 and 2, go ahead and tell me, is it arithmetic or geometric, and what's the common difference or common ratio? Okay, so go ahead and take a moment to do that. Pause your screen. All right, so when we take number 1, we see that I have 270, goes down to 90, goes down to 30, goes down to 10. So maybe I don't know what the difference is from 270 to 90, but I do know that 90 divided by 3 is 30. 30 divided by 3 is 10. So that means 270 divided by 3 is 90. So this is a geometric sequence. And I'm dividing by 3, so my common ratio is 1 over 3. 1 over 3. Okay, when we look at number 2, negative 24 to 12 to negative 6 to 3. So I'm increasing from a negative to a positive, decreasing back down to a negative, increasing back up to a positive. If you were to take the negative signs away, you would see that we are just dividing by 2 each time, which means we're actually dividing by a negative 2. Negative 24 by negative 2 is going to make a positive 12. Positive 12 divided by negative 2 is going to make a negative 6, and so on. So again, we have another geometric sequence here. It's again division, so it's not just -2, but my common ratio is going to be -1/2 or -1/2. All right, so today we're going to go a little further in and talk about the explicit and recursive formulas. We are going to put most of our attention on the explicit formula because that's what we use the most, but we do want to look at the recursive as well because it does tend to pop up with just a question or two here and there. Okay, so go ahead and make sure that you have your math notebook ready because you are going to be taking some notes today. So the first thing we're going to do is look at the explicit formula. Okay, so I'm going to do my best to use my mouse here the way I would use my pen. Okay, so you're going to copy this into your notes. If you want to title it, you can title your notes Arithmetic and Geometric Sequence Formulas, or you can call it what we saw back here, Explicit and Recursive Formulas. All right, so first bullet point, an explicit formula is based on the term. Okay, then the next thing you want to do for your next bullet point is write this down. An arithmetic sequence, or the arithmetic sequence explicit formula, is as listed. And we read that A sub n equals A sub 1 plus D times n minus 1. And I know right now you're thinking, you're crazy lady, what are you even talking about? Okay, you do not have to memorize this formula. Let me repeat that again. You do not have to memorize this formula. We will give you this formula on quizzes and tests. They will give you this formula on TN Ready. You do not need to memorize it. You do need to know how to use it. Okay, you do need to know how to use it, and that's what we're going to talk about today. So let's go back to reading it again. So I said this is A sub n equals A sub 1. These numbers that are down below, or I'm sorry, these numbers or letters, variables or numbers, that are down below, we call those subs. When they're up high, they're exponents. When they're down below, they're subs. Think about it like a submarine is below the water. So A sub n equals A sub 1 plus D times n minus 1. So we're going to talk about what each part of this equation means, which is going to be the next part of your notes. So what I would do next is, instead of writing another blank to fill in, I would draw a little arrow, and let's see if I can do it, to A sub 1 and label that as the first term in the sequence, and then draw another arrow to D and label that as your common difference. Your common difference. Now, it doesn't have it listed here, but later on, give me a second, I'm going to skip forward to see how we put it in here. Yep. Let me go backwards now. Okay. So for n, we're going to label it too, even though it's not on this screen. N is the term you are trying to find. Term, you are trying to find. It's really hard to do without a stylus. Okay, so again, A sub 1, first term in your sequence. D, common difference. N, the term you are trying to find. The term you are trying to find. Okay, once you get that part written in, then go ahead and add another bullet point, and we're going to copy down the equation for geometric sequence explicit formula. The only thing that it's missing is there should be, oh, that's my laser pointer, pen, there should be a little multiplication symbol like a dot right here. So we're going to add that in. So your explicit formula for geometric sequence, and again, you do not have to memorize this one either, it will be given to you, is G sub n equals g sub 1 times r to the n minus 1 power. So this one has subs and exponents, okay? So when you copy this down, again, we're going to forget about these two little blanks right here because this is technically for a foldable. We're going to draw an arrow to g sub 1. And you guys are going to label that as the first term in the sequence. You're going to draw an arrow to the r and label that your common ratio. And you're going to draw an arrow to the n, and it's going to be just like the one above, the term you're trying to find. The term you are trying to find. Sorry, but I'm not going to write that with my finger here because it would just turn into a mess. You can see how those arrows are looking, okay? Term you are trying to find. If you need to pause your screen now to get this copied down, please do so. All right, so write an explicit formula for the following sequences. Write an explicit formula for the following sequences. All right, so in order to do this, we are going to have to look at a few things. First, we're going to have to look to see what type of sequence it is, and then once we know the type of sequence, we'll know which formula to apply. So what I'm going to do is I'm going to have to get out of presentation mode. So I can maybe type on the screen. Oh, but I don't know if it's going to let me do that, guys. Here we go. Okay. Knew I would find a way to do this for you. All right. Here's my text box. Okay. So let me see if I can zoom it in. There we go. So my first sequence is -4, -6, -8, -10. So I can see I'm decreasing. I'm becoming more and more negative. Okay. It's decreasing by 2 each time. So that tells me I have an arithmetic sequence with a common difference of -2. So the formula we would write for this, we're going to use the arithmetic sequence formula over here. The explicit formula for arithmetic sequences. So A sub n, right now it's not a sub, but I'll make it one. A sub n equals, all right, for A sub 1 stands for the first term in the sequence. So my first term is a -4, all right? Then the next thing is plus D. I'm not going to put plus D though because it's only plus D if it is a positive difference. If it's a negative difference, it's going to be minus D. And we already said that my common difference is -2. So I'm going to put in minus, oops, and then 2. Then my parentheses, n minus 1. And then I'm just going to leave it like this. That is my answer. Okay. So I could change this to a sub. There we go. So my answer is A sub n equals -4, the first term in my sequence, minus 2, the common difference, times n minus 1. Right now we're not solving anything. We're just setting up the equation. Okay. All right. So we're going to go ahead and do another one. I'm just going to copy and paste this box, and we'll probably have to change it. All right, so number 2, we have 19 decreases to 13, decreases to 7, decreases to 1. So how would I get from 19 to 13? Nothing that I multiply or divide would easily get me there. But if I subtract 6, 19 minus 6 is 13, minus 6 is 7, minus 6 is 1. So again, I have an arithmetic sequence. So I'm going to use this same formula over here, the explicit formula for arithmetic sequences. I've already got my A sub n. So I'm just going to delete the rest out. So this time, 19 is my first term, my A sub 1. My common difference was minus 6, so I'm going to say minus 6, and then parentheses n minus 1. And again, I'm just going to leave it like that. All right. The next two are going to be geometric. I'm going to change this to G sub n. All right, so 25 increases to 75 increases to 225. Anytime you see a big jump like that, from 25 to 75 to 225, that should signal multiplication to you. So 25 times what is 75? 3. I could check in my calculator, is 75 times 3 225? Yes, it is. So I'm going to use the explicit formula for geometric sequences. So I'm going to start out G sub n, except it's making my G a sub as well, so I got to fix that. Okay, there we go. G sub n. Now, this one is a little different. So I'm still starting with G sub 1, the first term in the sequence, which is 25. But this time I have multiplication. So I'm going to get my multiplication symbol in here. Give me just a minute because I got to find it. Insert. There we go. Okay, 25 times. Then R, my common ratio. So we were multiplying by 3. So it's 3. And then I'm going to leave it n minus 1. But this time, remember, my n minus 1 is actually an exponent. I'm going to fix that in my typing. For you guys, you'll just be writing it, so it'll be easier for you. Okay? And again, I just leave it like this. G sub n equals 25, my first term, times 3, my common ratio, to the n minus 1 power. All right, one more example for explicit. Whoops. Sorry. Okay. All right. So this time we have 3, 9, 27, 81. Again, we're getting larger and larger and larger. So again, we're multiplying. 3 times what is 9? 3. 9 times 3 is 27. Yes. 27 times 3 is 81. Yes. All right. So this time, my G sub 1, my first term in the sequence was 3. My common ratio was 3, so that didn't change. And I'll leave it n minus 1. So I get G sub n equals 3 times 3 to the n minus 1 power. Let me pull everything back in. So if you didn't get any of these notes, again, go ahead and pause your screen. I would write the examples in as well and get that into your notebooks, because there's going to be a point when you have an assignment to do and you're going to need an example to look at. All right, up next, the recursive formula, So I put in red at the bottom. We won't use recursive often, but you need to recognize it at least. Okay, we didn't teach it at all last year, and then it showed up on the county benchmark, so we don't want to make that mistake again. So again, same note-taking format. We're going to start out with the very basic definition of what the recursive formula does. So recursive formula is based on the previous term, and then your first bullet point, the arithmetic sequences recursive formula is here. A sub n equals A sub n minus 1 plus D. And again, we're going to label it. Okay, we're going to label it. So A sub n is the nth term. And again, if you want to, instead of drawing the blanks, pen, you can draw an arrow and label n as the nth term. D is my common difference. You could draw an arrow to the D and label it common difference. And then this n minus 1 right here, that's the previous term. Okay, I'm going to attempt to write that, but it's probably going to look a mess. term. I did my best, guys. I did my best. Okay. So that's for the arithmetic sequence. For the geometric sequence, we're going to use the recursive formula for geometric sequences, which is G sub n equals R times, again, we need that dot in between. So R times G to the n minus, R times G sub n minus 1. So there are no exponents on this one. And again, we're going to label it the same way. N is the nth term. R is the common ratio. And then n minus 1 is the previous term. Okay. And I'm sorry, I should have explained. If you're wondering what the nth term means, the nth of something means any number. Okay, it means you could find any number, the nth term. All right, so go ahead and pause your screen to copy down your recursive formula. Then we're going to write a recursive formula for each of the following sentences. Sorry, guys. Okay, here we go. Zoom out a little bit. Alright, so I'm going to do like I did before and insert a text box to type in for you guys. Alright, so these are the same examples that we had for the arithmetic, for the explicit formulas for arithmetic and geometric sequences. Same sequences here. So if you remember from last time, number 1 was an arithmetic sequence with a common difference of -2. So this time we're going to use the recursive formula, which is A sub n equals A sub n minus 1. And then this time all we're going to do is put in the common difference, which is -2. Okay, and then I'm going to fix this to be subs. Give me just a second. This one's going to look really weird until we actually use it to do something. There we go. So it's going to look just like this, except it should be in lowercase a. There we go. All right. So the formula you would write would be A sub n equals A sub n minus 1 minus 2. All right. For the next one, it was also arithmetic. And when we found the common difference on this one, it was -6. So I'm going to have A sub n equals A sub n minus 1 minus 6. Alright, then the last two were geometric. So I'm going to switch to the geometric formula. Again, sorry, this is a little messier tonight than I usually am, guys. I just totally left that stylus on my desk today. Alright, so G sub n equals, and then we got to change some things around a little bit. So this time it's going to be R. So my common ratio was 3 because I'm multiplying by 3. I'm going to put in my multiplication formula, my multiplication symbol. Insert, and then it's times G to the n minus 1 power. So on recursive, all you're doing is plugging in that common difference or common ratio. Now again, eventually we will actually use these formulas to find something, but sometimes we're also just going to ask you to write the formula, and this is what you would put. It's going to be the exact same recursive formula for the next one because it also had a common ratio of 3. Anybody have any questions so far? If you do, make sure you email me. Okay, please, please, please make sure you email me. So again, just keeping it kind of basic today. And we're going to stop here, and we'll move into actually using the formula on Friday for my even students. And then my odd students, you guys are going to be a day behind since this is an even week. So you guys won't move on until next Tuesday. My even kids are going to get a little bit ahead of the game. But odd students, you'll have Tuesday, Thursday, Friday next week to get caught up. Okay, so no additional assignment today. Just make sure that you do your Microsoft form. It's in the announcements on Kidem. It's due by midnight on Wednesday, which is tomorrow. Then you will have another one that will be posted on Thursday. It will be due by midnight on Friday. Okay, if you are not able to attend the Zoom today, you do need to know that you will be marked absent each time you do not complete the Microsoft form or anytime you do not turn in an assignment when it is due. So remember, for my even students, your LHS Mastery is due today, Wednesday at 3:30. For my odd students, your LHS Mastery is due today, which for you is Thursday, again at 3:30. Have a great day, and we will continue at a later time.